Welcome friends to Boiler Room Detective Channel. If you enjoy these videos, please like and subscribe to the channel. This case is the case of how air got inside the hydronic piping. Understanding hydronic systems can be challenging. For years I struggled with the concept of pumping away, a term often used by industry experts like Dan Holohan. How does air get inside a system when the circulator is on the return, but doesn't do it when the circulator is on a supply? How does it know? Is air pulled in through the air vents? The answer, I soon discovered after banging my head, was that the air was already inside. Think of a hydronic system like a finely manicured lawn. Just like weeds are hiding in the yard, the air bubbles are always there, but they're under control. You may not see them, but they are there, waiting. The system static pressure, 12 psi, squeezes the air bubbles, keeping them small and manageable. The tiny bubbles are inside the water and expelled when they reach the air removal fitting. 12 psi is the most common static pressure for a two-story building. A circulator's job is to provide a pressure differential so the water can flow. In this case, the pump's outlet pressure is 4 psi higher than the inlet pressure. If the circulator is on the return, the pump outlet is facing the expansion tank. The expansion tank absorbs the extra 4 psi generated by the circulator. If the circulator can increase the discharge pressure, a pressure differential is created by lowering the inlet pressure. The inlet pressure for the circulator drops to 8 psi, and that's when everything falls off the rails. The bubbles that were in submission now expand and become more buoyant. This is especially noticeable on the top radiators. If you had pressure gauges at different elevations in a hydronic loop, you would see the pressure lowers the higher you get. The pressure on the first floor radiator is higher than the pressure on the second floor radiator. There's about 3 or 4 psi on the highest radiator. Those air bubbles, now freed, are going to munch on the piping and the boiler and restrict the water from getting where it needs to go. The buoyancy of the air bubbles causes it to rise and gather in the top radiators. To get the radiator to heat, the air has to be vented. When the circulator is on the supply pipe, pumping away from the expansion tank, the outlet pressure increases by 4 psi. This makes the circulator discharge pressure 16 psi and the inlet stays at 12 psi. Increasing the system pressure makes the bubbles shrink even more, making them even easier to remove. This results in less air venting required by the owner or service tech. If you would like to contact me, my contact information is here. In addition, I have 2 websites. Brewingwithsteam.com focuses on steam systems for breweries and distilleries. It includes a monthly blog about steam issues inside a brewery. My other site is fireiceheat.com. It's my company's website and shows some of our capabilities. I have authored 12 books on boilers which are available on Amazon. My technical articles are included in many of the industry publications, such as these here. Thanks for stopping by Boiler Room Detective, and I'll see you on the next case.